Nanotechnology is a very fast-growing area of research with many possible applications. Scientists are also working hard to understand and thus mitigate any potential negative side effects. The museum's Corinne Tate is here to talk about the latest research in this area. Hi, Corinne.
Hi, Susan.
So nanotech is a very broad term. What type of nanomaterials are we specifically talking about today?
So, nanomaterials in general is just a term we use for very small, tiny materials that we engineer or design. They tend to be on the scale of 1 to 100 nanometers, which puts them in the size range of our biological molecules. These things can be taken up into cells.
So today we're going to be talking about any harmful side effects that have to do with some of these inside of our body because they're so tiny. Would our cells recognize them as something bad, or can the nanoparticles actually harm the cells because they're on the same scale?
Well, that's exactly what researchers are trying to find out. There are two big areas of concern with nanomaterials. The first is that one of the many potential applications of nanomaterials is in medicine or drug delivery. So we want to understand exactly how these materials are going to interact with cells inside the body. And another area of concern has to do with manufacturing. When we use nanomaterials for different applications like computing and super strong materials, when we're actually making these materials, they're able to get airborne. When they're floating in the air, they can be inhaled and taken into the body that way, and they have the potential to be dangerous.
Is there a certain nanomaterial that they are specifically concerned with being in our bodies?
There are a few that they looked at. One was a carbon nanotube. Now, these are sheets of carbon rolled up into long, skinny tubes. They also looked at gold nanowires, and they focused on those for a few different reasons. One is that these are materials that are already used in a lot of applications, but also they chose these ones specifically because of their long, skinny shape.
Why is the long, skinny shape of concern?
Well, researchers noticed that it resembled another material, asbestos fibers. And we know that asbestos fibers can cause a lot of damage in the body. When they're inhaled, they lodge in the lungs and they can cause scarring and certain types of cancer. And what they noticed with asbestos fibers is that these long needle-like fibers would basically pierce the cells. And they'd seen images of these cells with these long, skinny fibers sticking straight out of it.
And so they were then worried, or they wanted to check to see if these nanotubes that look similar would also act similar.
Exactly. And this research was led by Haochen Gao from Brown University, an engineering professor there. And the first thing they did was look at scanning electron microscope images of these nanomaterials with these cells. And they noticed that it did the same thing as asbestos fibers. They were partially taken into the cells, but most of the structure was kind of sticking straight out at a 90-degree angle. You can almost imagine it like a toothpick sticking in a cube of cheese.
Now, normally, a cell is not able to engulf something that is much bigger than it, and so it doesn't even try to. Why would it be engulfing these things that are obviously too big for it?
That's a great question, and that was really what these researchers were trying to figure out. These nanomaterials, they say they have a very high aspect ratio. That means that their width is only a few nanometers across, but they're incredibly long. You can think about a carbon nanotube almost like a drinking straw, but instead of being, let's say, 8 inches long, imagine it was 800 feet long. So they're much longer than they are wide. And it's true that there's no way the cells could totally engulf them. Why on earth would they be trying to take these in?
I would guess, is it possible they can't tell how long it is because it is so far away they can't see the end? But it still seems like, why would they start anything that they're not sure they can finish?
Well, essentially, they're tricked into taking in these nanomaterials. What they found from a lot of observation in these computer simulations to figure out how the process would happen is that most of the time, the nanomaterial enters the cell tip first. Basically, the rounded tip of this structure touches the cell membrane, and the cell is fooled. It thinks just by that small rounded end, it thinks it's a small sphere. It has no way to anticipate the entire length of the material, so it starts taking in what it thinks is a small sphere.
And eventually it appears that it's bitten off more than it can chew.
That's right, Susan. So as it starts taking in the rounded tip, the material naturally rotates. The carbon nanotube will naturally rotate to a 90-degree angle, so it's perpendicular to the cell. And that happens naturally because it reduces the amount of energy that the cell needs to take that material in. But then as it starts taking it in, the vertical alignment basically fools the cell. It doesn't know how long it is. And by the time it figures out that it's much too big to take entirely within the cell, it's too late. You can't reverse that engulfing process, so the cell is stuck and it thinks it's being attacked. It basically calls for help. It triggers an immune response, and that causes repeated inflammation, and that's what leads to the damage from asbestos fibers or nanomaterials. This repeated inflammation can cause scarring and cell death and cause a whole host of other long-term problems.
And it seems that the piercing of the cell itself would probably kill the cell or damage the cell, even without the whole inflammation process as well.
Pretty much.
Does it always happen like this every time that they looked at it?
Actually, not always. It happened the large majority, about 90% of the time, the material would enter the cell that way. But interestingly, they found that carbon nanotubes without that rounded tip, if there was an open end to the carbon nanotube, they found that it actually didn't enter the cell at all. It would just lay flat on the cell membrane. And they hypothesized that those tubes must lack the ability to bind with the receptors that are on the cell membrane. But that finding kind of leads to a really interesting question that researchers are trying to explore now. Is it possible that we could modify or engineer the geometry of the tip, the end of the nanomaterial, to avoid this problem and possibly to make nanomaterials that are less toxic to our cells?
All right, I mean, just from what I've learned in the few minutes here, if you don't have that rounded edge on the end, it wouldn't fool the cells into thinking it's small enough for it to ingest. And that open end on the nanomaterial doesn't fool the cell and wouldn't hopefully cause the problems of sticking into the cell with the immune response and all inflammation. So that does seem like a promising way to go. What are their next steps for this?
Well, they're continuing the research to see how other nanomaterials, ones with different shapes and geometries, might interact with cells. But in general, they just want to make sure that this research isn't viewed as kind of a big blow against nanotechnology. The idea, rather, is that the more we understand how these nanomaterials might interact with the human body, the safer we can make them. We can engineer and design nanomaterials that are less toxic, and that way we can take advantage of all the potential benefits without unwittingly causing harm.
Yeah, it seems nanotechnology really is such a huge and promising field in medicine and energy and computers that you hate to just rule it all out. So it's good that the researchers are taking a proactive look at making these nanoparticles safe.
Definitely.
So I know a lot of people have been concerned about the use of nanoparticles, and so thank you very much for explaining some of the possible side effects of it, but also the ways that they are trying to mitigate those side effects.
My pleasure, Susan. Thanks for having me.
That's it for this week's show, but be sure to come back next time for more of the latest in science and technology. This podcast